Hello everyone, this is Ketish here. In this video, I'm going to go through the AQA 2020 Combined Science Physics Paper 2 Higher Tier. Question number 3 is on the topic of forces to do with spring constant, Hooke's law and elastic potential energy. So question 3, figure 5 shows a computer keyboard. There's a spring under each key. The springs behave elastically when a force is applied. What is meant by elastic behavior? Now, elastic behavior is when it's obeying Hooke's law. The spring will be compressed when the force is applied to it. That's not elastic behavior. The spring will become deformed when the force is applied to it. That's not a elastic behavior as well. The spring will become longer when the force is removed. No, that's not true. It's true, but that's not elastic behavior. The spring will return to its original length when the force is removed. That's correct. Elastic behavior is when it goes to the original length. Question 3.2, suggest two properties that should be the same for each spring. So they're referring to all the springs in the keyboard. Now, all the springs should be identical. If they're identical, then they should all have the same spring constant. They should all have the same length and diameter as well. So any two of these should give you the 2 marks. Question 3.3, figure 6 shows one of the keys and its spring. Here you've got the spring and there's a clearance of 0.004 meter. When you press it, it will actually go down. The key must be pressed with a minimum force of 0.8 Newton. So that's your force. Before the key touches the switch, calculate the spring constant. So this is my extension, is my actual compression. We can use the same equation, calculate the spring constant. Force equals the spring constant multiplied by the extension. Now, most students would actually think, well, the spring is not extending, it's compressing, but you can use this same equation. So 0.80 equals the spring constant, which is K, multiplied by the compression 0.0040. Rearranging the equation, spring constant equals 0.80 divided by 0.0040. That gives me an answer of 200 Newton per meter. The answer is 200 Newton per meter. Next part. Question 3.4, figure 7 shows a spring that has been hung from a support. The spring is stationary and has been stretched beyond its limit of proportionality. Now, if it's gone beyond the limit of proportionality, that means the spring is deformed. It's not going to go back to its original length if the masses are actually removed from here. Because it's stationary, the downward force because of the weight of the masses is equal to the upward force because of the tension in the spring. Which two statements are true for the spring? The elastic potential energy of the spring is 0. That's not correct. The extension of the spring is directly proportional to the force applied. No, it's inelastically deformed. The upward force on the spring is equal to the downward force. Yes, that's correct. The spring cannot be stretched any further. No, that's not correct. And the spring is inelastically deformed. That's correct as well. That brings us to end of question number 3. And I will see you in question number 4.